In this video, we're simply going to be looking at the 1100 tutorial sheet 5. And the first question says, use Pascal's triangle to expand each binomial. So question 1 has to do with the Pascal's triangle, and we know how to formulate the Pascal's triangle. So I'll start with question number 1, which just says x plus 2y to the power 5. When we create the Pascal's triangle, we need to look for the step that gives us n is equal to 5. So the first staircase is 1 and 1. Then the second staircase, we put 1s this side and we add these subsequent terms. This is going to give us a 2. Then again, we do the same. So this is going to give us a 3. This is going to give us a 3. Then this is going to give us a 4, a 6, a 4, and a 1. So on 5, we're simply going to get a 5, a 10, a 10, and a 5. So this is when n is equal to 5, when the power this side is 5, right? These are going to be the coefficients that we need to use. So now, assuming that you already have learned and now you just want to learn how to apply the principles you learned from the topic, we know to say you have to write the coefficients like this. These are the coefficients from the Pascal's triangle. This is what you always do whenever they tell you to expand using the Pascal's triangle. Then we always know that the first term has to be decreasing as we move from left to right. So you notice the first term is decreasing in terms of the powers from left to right, and the second term, which is in blue, is increasing from left to right. Now the portions that have 0 as the powers, there's no need to actually show them. We can just like omit them. So these parts don't have to be shown because we know they won't change anything. Those should be 1s. Then from here now, we simplify it and get something that is going to be x to the power 5. This is going to be plus, this is going to be 10, x to the power 4, and y, this is going to be plus, this is a 40, x to the power 3, and y to the power 2. Because of the 2y squared, this is going to give us 80, this is going to be an 80, x squared, and y to the power 3. Then this will be plus 4 to the power 2 is simply 16, 16 by 5. That's simply going to give us an 8 as well. This is y to the power 4. Then lastly, we have a 32, y to the power 5. So this will be taken to be the expansion of the first part of question 1. This guy here, that's the expansion. So it's the same principle for everything. And if the second term is attached with a negative, we carry the negative on our expansion. So I'm also going to expand this guy here, number 4. So that you see the power is 4 as well. So we are having this is going to be, so IV, this is 2 minus x to the power 3, this is the power 4. So the coefficients are simply 1, 4, 6, 4, and 1 according to your Pascal's triangle. And we say the first term has to decrease. This is what we have. This is a 2, and then this is a 1. Then the second term has to increase, so we're just going to start from here, x to the power 3, then x to the power 3 squared, then x to the power 3, then negative x to the power 3 with a 4. So to simplify the working here, this is just going to give us a 16 minus, this is going to be a 4, 2 to the power 3, that's 8. With an x to the power 3, then this is going to be plus a 6 to the times 4, then x to the power 6, then this will be negative 8 x to the power 3 by 3. That's simply going to be a 9 because the 3s are multiplying. X to the power 3, we're multiplying this guy by itself 3 times. That's what we're basically saying. So we're just going to add the powers, giving us a 9. Then the last one will simply be a positive. This is x to the power 12. To simplify the working here, we're just going to get 4 by 8. That's simply going to give us a 32, x to the power that. Then this is a 24. There are no like terms here, so everything just remains as it is. So these are the terms of the expansion. This is what you get for part 4 of question number 1. So the principle is the same, and you notice that all the questions, they gave you something that has a 7 here. It's still the same thing, meaning you have to make a Pascal's triangle until you get the 7, which is, I'll start from 5. So this is 10, 10, 5, and 1. You can go to 6. So it'll be 15, 20, 15. Then you have 6, you have 1. You go to 7. This is 7. This is a 21. This is a 35. 35. This is a 21, 7, and 1. So these are the coefficients that you're going to use for this part. Yeah, so let me try the last one. This is 2x plus 1 over x to the power 6. And the good news is that in an assessment, in a test, or in the exam, they will never give you a power which exceeds 5. Yeah, so this is question 1, VI. They want us to expand this using the Pascal's triangle. We already know what the coefficients are when n is equal to 6, right? These are the coefficients there. So simply write our expression. This is just going to be 1, 6, then that's a 15. We have a 15, then that's a 21, if I'm not mistaken, or 20, I mean. Yeah, so that's going to be a 20. From there we have a 15, then we have a 6, then we have a 1. That's what we have. Then we're saying the first term, so I'll write the terms here down. This is 2x to the power 6. Then I'll write my 2x there down to the power 5. Because of space, right? I'm just trying to show them down. This is to the power 4. This is 2x to the power 3. This is 2x to the power 2. This is 2x to the power 1. Then this is 2x to the power 0. Then the other term is this one, the second term, which is 1 over x to the power 0, 1 over x to the power 1, then 1 over x to the power 2, and 1 over x to the power 3, and 1 over x, then 1 over x, and then lastly you have this 6. So now to write this properly, I'm going to deal with this part here. 2 to the power 6, that's a 64, if I'm not mistaken. Then I'm having x to the power 6. That's all. This is just erased because it's a 1, right? And this doesn't change anything. Then from here, we're having positive. This is 6 multiplying 2 to the power 5. That's a 32. So I'm having a 32 here. Then there's x to the power 5. Then down, I'm having this because this is a fraction, right? So it's going to come down there. Then here, I'm having a 15 times 2 to the power 4. That's a 16. Then x to the power 4, then downward I'm having x to the power 2, then here I'm having a 20, this is simply 8, x to the power 3, then downward I'm having x to the power 3, plus a 15 and a 4, x squared. This here is simply 1 over x to the power 4, so multiplying by 15, 4, and x to the power 2, that's the reason why we are saying it's simply going to be 15 times 4x to the power 2 over x to the power 4. That's what we get for this term here. Then we go to this other one here. That's going to be a 6, 2x, then there's an x to the power 5 there. Then the last term is simply 1 over x to the power 6. Then we simplify and cancel things that are common between the numerator and the denominator. So this is simply going to be simplified as 64 x to the power 6, then plus having a 6 by 32, which is just 192. This is a 192. 1x can cancel with 1x there. That's going to give us x to the power 4. Then here we're having a 15 by 16. That's 240. This is a 240. Then 2x's can cancel with 2x's there. That's going to be x to the power 2. Then here we're having, this is going to be 8 by 2, that's a 16, so 160. We can cancel the 3x's, that's just 160. Then this is going to give us a 60 over x to the power 2, because 2x's can cancel with 2x's at the bottom. Then here we're going to get a 12. 1x can cancel with 1x here, this is going to be x to the power 4. Then plus 1 over x to the power 6. So this is the answer to question number 5 on part 1. So this is basically how you're supposed to use the Pascal's triangle. Hope this makes sense. The next question, so we're going to question 2. So even the ones that I've skipped, you do them in a similar way. These the ones that I've skipped. Question 2 says, find the first 3 terms in the ascending powers of x for the binomial 3 minus 2x to the power 5. So we're still going to use the Pascal's triangle because the power is positive. Whenever the power is positive, you can always be using the binomial theorem or the Pascal's triangle. They will still give you the same result. So we are having question 2. This is 3 minus 2x then to the power 5. The coefficients when n is equal to 5 will simply be 1, 5, is 10. Now they just say the first 3 terms, meaning we don't have to write all the coefficients. We just need the first 3 terms, which are just these. Then this is going to give us 1, 3 to the power 5, and negative 2x to the power 0. Then plus a 5, 3 to the power 4, and negative 2x to the power 1, plus a 10, 3 to the power 3. Then this is negative 2x to the power 2. We were supposed to continue, but then we're not going to continue because we're not interested in everything, but only the first 3 terms. So here we're going to get a 243, then plus, this is going to be minus because we're having a negative and a positive there, right? So this is going to give us 3 to the power 4, then by 5, then simply by 2. That's going to give us an 810. This is going to be an 810 with an x. Then this here will be positive. This will be 3 to the power 3, then multiplied by 10, then multiplied by 4. That's going to be 1080 x squared. So this is basically what they wanted. Instead of expanding everything, we know here it's 5, then this, we're supposed to have something that looks like this. But then because they just specifically wanted the first 3 terms in the ascending powers of x, meaning in the expansion, they knew that the values or the x powers are going to be ascending. So this is basically what we're having. Yeah, so this is the answer to part 2, our question 2. Then the same thing with number 3, we're also going to use the Pascal's triangle because this is just exactly similar to part 5 of question 1. So we're simply going to do it in a very similar way. They want it in the simplest form, meaning if there are parts that can cancel, we have to cancel them out. So this is just going to be x. So this is question 3. So if anything, like I said, the method here is the Pascal's triangle that we're using. So you can pause the video and attempt it first before you actually see how we're going to do it. This is to the power 5. So the coefficients are 1, there's a 5, there's a 10, there's a 10, there's a 5, and there's a 1. So this is just going to be, so this is what we're going to have. The first term decreases and the second term simply increases. The coefficients are simply 1, 5, 10, 10, 5, and 1. So this is going to give us x to the power 5. This is plus 5, x to the power 4, then x. And this is going to be 10, x to the power 3, x squared. Then this is 10, x squared over x to the power 3, plus a 5, x and x to the power 4, plus this is 1, x to the power 5. So if we reduce this, this is just going to become x to the power 5 plus, we cancel 1x and 1x here between the numerator and the denominator. This is just going to be x to the power 3, and this is going to be 10x. Then this will just be a 10 over x, then this is going to be a 5 over x to the power 3. This is 1x to the power, this is 5. So this is going to be the answer of question 3. Because they want this in simplified form. So in the simplest form, where we don't have anything else that's left to cancel out, this is what you're going to get. So this is going to be your answer for part number 3. Then part number 4. So question number 4 is simply telling us that we have a quadratic equation that has alpha and beta as the roots, and we know how alpha and beta should be related. We know to say alpha plus beta is equal to negative b over a, and we also know alpha times beta is simply your C over your A. Now they want us to get the actual value of alpha cubed and beta cubed, and also alpha to the power 4 and beta to the power 4. So the first thing that we're going to do here is to find an expression that will be easy for us to handle in terms of alpha plus beta and alpha times beta. So we're having the quadratic is simply 3x. This is 3x squared, then plus a 5x, then plus 4 is equal to 0. This is the quadratic whose roots are alpha and beta. That's what they're saying. We know alpha plus beta according to this is equal to negative 5 over 3. And alpha times beta is simply a 4 over 3. That's what we have. Now, they want us to get the first one is alpha to the power 3 and beta to the power 3. That's what they want. So we'll simply use the Pascal's triangle and expand something that will yield what we have here. So we are going to use alpha plus beta, put the power which is here, which is simply 3, and expand this using the Pascal's triangle. When you do so, you're simply going to get alpha to the power 3 plus 3 alpha squared and beta plus 3 alpha and beta squared, then plus beta cubed. When you use the Pascal's triangle to expand this, you simply get this because the coefficients are 1, 3, 3, 1, right? Then from here, we're trying to come up with this. This is what we are looking for. So now we're going to make alpha cubed and beta cubed to be the subject of the formula by taking everything else on the other side. So we're simply going to have alpha plus beta to the power 3 minus 3 alpha squared and beta. I've taken this part here, and I'm also going to take this part minus 3 alpha beta squared is equal to alpha cubed and beta cubed. So at least now we have an expression of alpha cubed and beta cubed. So the expression now can be written to say alpha cubed and beta cubed is actually the same as alpha plus beta cubed, then minus 3 alpha squared and beta minus 3 alpha and beta squared. So that from here now we can factorize, so this is going to be, you can factorize what's common there is a negative 3 and alpha and the beta. What remains from here is just an alpha. What remains there is just going to be a beta. You notice that if you multiply this, you get back what you had. Then we can do our replacements because we know what alpha plus beta is. It's negative 5 over 3 cubed, then minus 3. This is simply going to be a 4 over 3. Then we know this is negative 5 over 3. We get the actual value of alpha cubed plus beta cubed. This is going to give us a negative 125 over a 27. Then this will be a positive. The 3 will cancel with this 3. This is just going to give us a 20 over a 3. And then if we sum up this, the common denominator is going to be 27. This is going to be negative 125 plus. So 3 into 27 is just 9. 9 times this is 180. So we're just saying 180 minus a 25. So this is going to give us a 55, if I'm not mistaken. This is 27. And since we cannot reduce this any further, this is basically going to be the summation of alpha cubed plus beta cubed. That's basically what you have. So hope this is okay. The next question on number 4, part B, is simply alpha to the power 4 plus beta to the power 4. So the same thing is also going to be done here. We don't have an exact expression that gives us alpha to the power 4 and beta to the power 4. So now for them to ask this question under binomial topic, meaning we have to apply something that we've learned, and the only thing we've learned so far is the Pascal's triangle. So we're going to use the Pascal's triangle to expand alpha plus beta to the power 4, the same thing that we did for the previous question. So when you expand this using your Pascal's triangle, the expression you're going to get, to say the coefficients are supposed to be 1, 4, 6, 4, 1, right? The first term has to decrease in terms of the power, so this is going to be that. This is a 3, this is a 2, that's a 1, and the second term has to increase, That's a beta, beta 2, then beta to the power 3, then beta to the power 4. So meaning we're just saying alpha plus beta to the power 4 is the same as alpha to the power 4 plus 4 alpha 3, then beta plus 6 alpha squared and beta squared. Then this is a plus. So you just get this. This is beta to the power 4. The same thing that we did, we make alpha to the power 4 and beta to the power 4 to be the subject of the formula. So we take these three things, this guy and this guy, on the other side. So we're just going to have alpha plus beta to the power 4 minus 4 alpha 3, then beta, then minus 6 alpha squared and beta squared, minus 4 alpha and beta cubed, to give us alpha to the power 4 plus beta to the power 4. That's basically what we have. Then we can rewrite this. So alpha to the power 4 plus beta to the power 4 is the same as alpha plus beta to the power 4 minus 4 alpha beta, then this is going to be 6 alpha squared and beta squared minus 4 alpha and beta cubed. This is going to give us the same thing as alpha to the power 4 and beta to the power 4. So we're going to put it in a way that will be okay. So like from here, I'll factorize. The common thing is negative 2 alpha and beta. That's the common thing. What remains here, there's going to be a 2 alpha squared. Then there's going to be a plus 3 alpha beta. Then plus, this is 2 beta to the power 2. That's what you have. If you multiply, you should be getting back what you had there. So this is going to be alpha plus beta to the power 4 minus 2 alpha beta. Here I'm just going to say 3 alpha beta. I'll bring these two close so that it's going to be 2 alpha squared plus 2 beta squared. Then this is going to be alpha plus beta to the power 4 minus 2 alpha beta. Then there's 3 alpha times beta. Here the common thing is 2, open brackets, you have alpha squared and beta squared. This is what you have. Now you learned that this, recall, according to your alpha and beta, you learned the equations, that alpha squared plus beta squared, you learned this to say this is the same as alpha plus beta squared minus 2 alpha beta, right? You learned this. If you've forgotten this, there's a separate video that just talks about alpha and beta. It's titled alpha and beta. You can just have a fresh reminder of what you did. So we're going to replace this part here where there's alpha squared and beta squared. So now we're saying alpha to the power 4 and beta to the power 4 is equal to alpha plus beta to the power 4 minus 2 alpha beta. Then this is 3 alpha times beta plus 2. Where there is this, we're replacing this part because alpha squared and beta squared is this, right? So here we're going to put alpha plus beta squared minus 2 alpha beta. That's what we have. So now we have the full expression for alpha to the power 4 and beta to the power 4. We can now do the replacement. We know what this is. It's a negative 5 over 3 to the power 4 minus 2. This is a 4 over 3. And this is just a 3. This is a 4 over 3. Then plus a 2, which is just negative 5 over 3 squared minus 2. This is a 4 over 3. So this is what we have. Then we just compute everything here. This will give you the following. So this is what you get as the final answer after you just do the replacement. So this is how you are supposed to do it. The main part is you deriving the same expression for alpha to the power 4 and beta to the power 4. That's the most important part. So hope this makes a bit of some sense. And this is what was needed here on question number 4. They wanted us to get actual values of this. Now part 5, this is just the same thing that you are doing when you're looking at the alpha and beta things on under quadratic equation. So here they've given us a quadratic. They want us to find another new quadratic equation whose integral coefficients are these. So I'm just going to do the second one, then I'll give you a chance to do this. Then you can just check it out. You can verify, with me on WhatsApp to see if you're actually following what we are doing. Yeah, so this is how you're going to learn this, by practicing. So here we're going to say, we already know according to this, the formula is still the same. Alpha plus beta is this. So according to this quadratic, your alpha plus beta is going to be negative of your b over your a, right? Then your alpha times beta is just going to be your c over your a, which is just a 5. So alpha plus beta is simply 3 over 5. And your alpha times beta is negative 1 over 5. So now they're asking us to get a quadratic equation whose roots are these two. So we need to get the sum and the product of these two roots that we are given. That is if we are creating something else that's different. So that's question number 5. Yeah, so question number 5b is the one that I'm doing. Then you attempt number 4. The first one, because the first one is a little bit easy. No wonder I'm suggesting to do this one here. So they're given us alpha squared. So there's alpha squared over beta, and there's beta squared over alpha. That's what we have. So now we're looking for the sum. So the sum is just going to be, we add them, alpha squared over beta plus beta squared over alpha. This is equal to alpha times beta. Then this will be alpha to the power 3. Because we're just multiplying, right? This and that. This is going to give us beta to the power 3. Now we already know what the guy on top is. We know what alpha cubed and beta cubed is. We're from getting such an expression. It's the same as 3 alpha beta. Then we have alpha plus beta. That's what we know. The guy at the bottom is still intact. Then we can just do the replacements. Alpha plus beta, here we got it to be 3 over 5. So it's 3 over 5 to the power 3 minus 3. Then here we're getting negative 1 over 5. Then this is going to be, the sum is 3 over 5. The product is negative 1 over 5. So this is just going to be a 27 over 125 plus, this is going to be a 9 over a 25. Then this whole thing is being divided by negative 1 over 5. This is just the same as 27, 125 plus 9, 25 times negative 5 over 1. This here is the same as 5 there is 1. Then we are having 125 divided by 5. That's going to give us a 25. So this is 27 over 25. Then we are having plus, this is a 9 over 5. Of course, there's a negative there. So it's negative 5 and 5. That's 45. So we're just going to say 9 by 5. Plus 27. So when you sum up this whole thing inside here, you need to get a 72 over a 25. That's what you get. So the answer is negative 72 over 25. So please do correct me in case I'm wrong, because I'm doing this a little bit fast to save on the time. So this is the sum that we're getting because of adding this. It's negative. Then the product would have just been alpha squared over beta multiplying beta squared over alpha. This will just be alpha and beta squared, then alpha and beta. So 1 alpha and beta cancels with 1 alpha and beta on top, so meaning we're just remaining with alpha and beta 1. So this is just the same as negative 1 over 5, implying that the new quadratic whose integral coefficients are these two is simply going to be x squared minus the sum x, then the product is equal to what? 0. Now we know to say the sum was negative 27 over 25 with an x, the product is negative 1 over 5. This will just be x squared plus 27 over 25 x minus 1 over 5. We can multiply throughout with a 25 to make things to be in a linear. So this is going to be 25x squared, then plus 27x, then minus 5 is equal to 0. So this is what you get. This is what was needed for question number 5. That's what they wanted us to do. So it's the same thing that you do here. You add them and multiply them. You get the sum and the product. So that's your question number 5. Then question number 6. So question 6 is on factorials. So you know what factorial means. So factorial, just a reminder, means n minus 1, minus n minus 2, n minus 3, until you reach a 1, right? So if they ask us to say, they're asking us to say n plus 1 factorial, so the factorial is outside here, is equal to 5. The factorial here is just with the n. So this is the same as, we can reduce this, right? This is the same as n plus 1. Then n factorial, this is the same as 5 and n factorial. We can now cancel the n factorial, meaning n plus 1 is equal to a 5, meaning n is equal to 5 minus 1, implying that your n is equal to a 4. So this is what you get. So this is how you were supposed to answer number 6, where they say that we should solve for n. So we should be careful to notice the difference. Here, n factorial is not together with the 5. They're just like next to each other. By not together, I mean if they wrote them like this, they would have taken this guy to be together. Yeah. So this is what I mean, that they're separate and not together. And the next question, number 7. So number 7, they're just saying show that n choose 1 is equal to n, and also n choose 2 is equal to this part here. So this is a very simple proof. I'll just show it right there. So this is, let me just show it. I'll show the first one here. So to answer the first part, n choose 1, we need to show that this becomes n. So we pick the left hand side, which is n choose 1. This is equal to n factorial, n minus 1 factorial, then we have 1 factorial there. N factorial is the same as n and n minus 1 factorial. I'm just expanding it enough to see the guy which is at the bottom. 1 factorial is still 1, so I don't change anything. So I want this and this to cancel. That's how I'm getting what? N. So I hope you remember the definition of n factorial. We said n factorial is simply n times n minus 1 times n minus 2, and so on and so forth. Yeah, so once we see the guy which is in the denominator, like here, if I give you 8 factorial over 7 factorial, this is the same as 8 by 7. Once I see 7, which is there, we put a factorial there, because I know 7 by 6 by 5, that's the same as 7 factorial. So we can cancel this part, just remain with it. Our n, this answers, so here we show this is equal to, we show them this is equal to the right hand side, hence shown, because they knew what it's going to be. We're just showing, right? That's what you get. Yeah, so this is your number 7. Number 7(2), they're saying we need to show that n choose 2 is the same as n times n minus 1 over 2. So this is the same as n choose 2 is the same as n factorial. This is n minus 2. So I'm picking the left hand side again. This is 2 factorial and 2 factorial. This is equal to n factorial. I have n minus 2 factorial and 2. This is going to be n and n minus 1 and n minus 2 factorial. I'm having n minus 2 factorial there. I'm seeing this guy, so this guy can cancel to give us n. This is basically what you get, which is equal to the right hand side. That's what you have. So this is how we get to show proofs. When we pick the right hand side to be equal to the left or the left to be equal to the right, meaning you've shown your working. That's basically what you do whenever they say show. Yeah, so this answers your number 7. Then number 8, they want us to simplify until we cannot simplify any further. So if we are simplifying the first one, they're just saying this part here, number 8. So we have 2n plus 2. This is a factorial over your 2n, then factorial. This is just going to be 2n plus 2, right? The original thing that you had. Then now subtract 1 from this. So what is 2n plus 2 minus 1? That's just going to be 2n plus 1. Again, subtract a 1 from here. That's going to be 2n now. Put a factorial. Then the guy down is 2n with a factorial. These two can now cancel to just give you 2n plus 2. And you have your 2n plus your 1. So this, you can multiply them, but this is just like the simplest version. Because if you multiply them, you don't have to factorize them again, right? Someone else here will say, here 2 is common. We could have actually written it like this. Someone can decide to write it like this. It's still the same because they can just factorize this 2, which is right here. That's what you get, meaning you've simplified it. So you can pause the video and try the second one. We see what you get. Okay, so we're having n plus 1. So there's n plus 1 on top on the numerator, then there's n minus 1. So you ask yourself, which of the expressions between the one in the numerator and the one in the denominator is smaller? N plus 1 is bigger as compared to n minus 1. So meaning we're going to be reducing the big one. So this is n plus 1. Then we're having n. Then we're having n minus 1 factorial. As soon as we see the guy which is in the denominator, we stop. So this is now going to cancel with that, so that we're just going to get n squared and n when you multiply these two. So this is how we have to find ways and means to reduce or simplify whatsoever you are given, using the same definition of what factorial implies. So that's question number 8. Then look at number 9. So question 9 says, write down the value of a in the following expression given. So like the first one, they told us the left hand side is 50, choose 13. It should be equal to 50 factorial and 13 factorial and a factorial. So this is what we are going to have here. So we'll start with the left, simplifying it in comparison with the right hand side. This is supposed to be 50 minus 13 factorial. According to that formula, the first formula that you learned under permutations and factorials, this is the formula that we're using. Then this is r factorial. So here we're going to get 13 factorial there is equal to 50 factorial, and then 13 factorial and a factorial. Now, we already know to say your 50 minus your 13 is a 37. So this is a 50 factorial. Then you're having a 37 factorial and a 13 factorial, which is 50 factorial and 13 factorial and a factorial. Meaning, the only thing that is missing on the other side is 37. These two guys will be the same. So if I cancel the 50, I cancel the 13, I'm only remaining with a factorial being equal to 37 factorial, meaning a is exactly the same as what? A is 37 for these two sides to be equal. That's for the first case. The same will be done for the second case. Now we are going to have 35 factorial and 35 minus a factorial, and then we're having a factorial. This is equal to 35. This is a factorial and 18 factorial. We already have 35 and 35, a factorial and a factorial, 18 and this guy. So we're just going to say 35 minus a is equal to actually 18. The factorials can cancel out. So we'll have negative a is equal to 18 minus 35. So 18 minus 35, that should be a 17. So this is negative 17, this is negative 17, implying that a is equal to exactly 17. So this is how you get your 2 a's for your question number 9. So we follow the same equation, and then we try to equate things that are appearing to be the same. What remains, in short, when the similar things cancel out, like here how the 50 and the 50 cancelled, and the 13 and the 13, then we equated what is here to be the same as a, which is giving us our 37, 35, and a and a goes away, meaning 18 is the same as 37 minus a, because the both sides have to be equal. That's what they're telling us. Yeah, so number 9 is done. So look at number 10. Number 10, we're just going to be using our formula. So number 10, I'll just show you how we do all of them. So the first one is 4, choose 2. This is the same as 4 factorial. 4 minus 2, that's 2. Then write the 2 factorial. This will just give you 6 by the time you're done solving, right? So hope you're okay with that, because 4 factorial is simply going to give you a 24. Then 2 times 2, that's going to give us a 4. So 4 into 24, that's where the 6 is coming from. Yeah, so 8 choose 5. 8 choose 5 is the same as 8 factorial. 8 minus 5, that's 3 factorial. Then write the 5 here. So 8 factorial, 8, 7, 6. Then we end on 5 factorial. 3 factorial is simply 6. Then we're having a 5 factorial. I can cancel this. The 6 and the 6 can cancel, meaning we just have 8 by 7, which is just a 56. So this is basically the number of ways that you can choose 5 things from 8 things is just what? 56 ways. These are like the options that you have. Then this one here, by the time you're done solving it, you just give you a 1. A 12. How many ways can you choose one thing from 12 things? There are 12 ways, right? You have 12 options. If you are given 12 options, then you're supposed to pick one, meaning you have exactly 12 options to select from. Yeah, so that is the answer you're going to get here. Then for the last one, that's n and n minus 1. This is the same as n factorial. This is n minus 1 factorial. Then we have n minus 1 factorial. This is just n factorial. This will just give you n minus n, then plus a 1 factorial, and then n minus 1 factorial. This will be n factorial. This is just going to be 1 factorial and n minus 1. This will end up being n factorial. The 1 factorial is just a 1, so I can just ignore it. This here can be rewritten as n minus 1 factorial, and this is n minus 1 factorial. We can cancel this, meaning this is just the same as n. So I hope this makes a little bit of some sense. This is what you're supposed to get. Yeah, so this is what you have. Then your number 11. Number 11, they're just saying, show that n choose n is equal to n choose 0. They are both supposed to give us a 1. That's what we want to show. So n choose n choose 0. They should give us a 1. That's number 11. I'll start with n choose n. N choose n is just n minus n factorial and n factorial. This is equal to n factorial, 0 factorial and n factorial. This will be n factorial and n factorial. This will just be 1. Again, n choose 0 is the same as n factorial, n minus 0 factorial and 0 factorial. This is the same as n factorial and 0 factorial, which is still going to be n factorial and n factorial. This should be 1. Hence, you put up a conclusion. N choose n is equal to n choose 0. They both give you what? 1. So that's what you do on number 11. Then number 12, they're saying write down the binomial expansion of this. So we're going to use the Pascal's triangle for this one. The same way you did the first question, which I gave you, which had the power to be 7. This guy here, the same thing that you did. The coefficients you're going to use are these ones from the Pascal's triangle. That's how you are supposed to do the next question there that we are having. So this is going to be too long if expanded, but please remember that the first term decreases from left to right, and the second term, which is negative 5y, is going to be increasing. Yeah, so you can try this as your task just to see if you're following what we're doing. So you can please feel free to do your confirmation on WhatsApp. Yeah, so this is the WhatsApp line. You can just confirm you're working. It's going to be very long, but like I said, these type of questions are given because they know this is a tutorial sheet. You have all the time in the world to compute whatever they're asking you. In an assessment, they'll never ask you something that has a power greater than 5. It's always going to be less than 5. If the power is greater than 5, meaning they just want you to get a certain term without expanding everything. That's using the binomial theorem. You'll see like the other questions down there. Yeah, so like these questions here, like question number 13. Now this has to do with the binomial theorem. So the binomial theorem here is just asking us to get a particular term from the whole expansion without expanding everything. And the formulas that we use for the binomial theorem are just two. So we're saying any term, the nth term you're looking for is always going to be given like this, provided you have a plus b and n is positive, meaning any term you want is the same as this. This is the term. Any term you're looking for is going to be given by this. So like question number 13, the first part they're saying, write down the terms indicated in the binomial expansions of the following and simplify your answers. So in short, they're just asking you, what is the term that has x to the power 5 in the expansion of this? So you see that the powers are very big, right? Like the 12. You cannot expand everything. You can, but then it's just going to take so much time for you to actually expand everything and then get the term that has x to the power 5. So we prefer using the binomial theorem because it goes direct. So this here, question number A. So here I'll do everything. So question 13. So question 13a, we are given x plus 2 to the power 8. We're looking for a term that has x to the power 5. So we'll say our n is 8. R we don't know. The first term we know it's x. Then it's 8 minus r. The second term we know it's a 2 to the power r. We don't know what this is supposed to be, but we're saying by the time we're done solving it, the term will have x to the power 5 alongside it. So now we're going to get the portions that have x, which is this part and that part. So we equate them. This is x. 8 minus r is equal to x to the power 5. So ignore anything that doesn't have x. So this is what we have. Then we equate the powers because the bases are the same. 8 minus r is equal to 5. When you solve here, 5 minus 8, that's r is equal to 3. So meaning r is equal to 3. And if r is equal to 3, remember what we have here, meaning 3 plus 1, right? So the term that we're actually looking for is the fourth term. So it is the fourth term that has x to the power 5. That's what we should know. Then we can actually get it because we know our r now. Now that we know our r, we can replace it back here so that we can now say 8 choose our r is 3. The first term is x to the power 8 minus 3, that's a 5. Then the second term is 2 to the power 3. Now we already got something like this. 8 choose 3 if you solve it separately. This guy, if you solve it, it will give you 56. Then you have x to the power 5. And then you have 2 to the power 3, which is just going to give us 2 to the power 3 is simply what? Simply 8, right? When you multiply, this is going to be 4. 4, 8, x to the power 5. So this is the fourth term. That's what they mean by simplify. Find the term and simplify. So this is how we're supposed to do such a question. The same applies to the next one. So here I'll do everything on number 13. The next one again, the wanted term that has u to the power 3. Again, we'll do the same. We'll say 5 r. We don't know what the r is. 3 u, 5 minus r, and negative 2 to the power r is equal to u to the power 3. Then from here now, we get the u, just the part that has u. Ignore anything that doesn't have u. Anything that's not u, ignore it. So the 3 is going to be ignored as well, but just get the u. So u to the power 5 minus r, that's u, 5 minus r, equate it to the u this side. the u to the power 3. Then equate the powers now. 5 minus r is equal to 3, meaning by the time you are done solving, your r is equal to 2. And if your r is equal to 2, meaning we're looking at the third term, 2 plus 1, right? So it is the third term which has u to the power 3. Now we can actually get it. So this is going to be 3u minus 2 to the power 5. So we can say 5, choose 2. This is 2, then we're saying 3u. This is going to be a 3, negative 2 to the power 2. So 5 choose 2, we can just solve this using the formula. This is 3 factorial and 2 factorial. This is a 27, u to the power 3, and this is a 4. So this is going to be 5 choose 2. The answer should be 10. Then 10 by 27, 10 by 4. So it's going to give us 10, 8, this, u to the power 3. So this is the third term that they wanted. So this is how we basically do the second one. Yeah, so you can pause the video and attempt the last one. We see if you get it right before we do it together. Okay, so this one here, they're just going to say 12, choose r. Then we have 2t to the power 12 minus r. Then we have negative half to the power r. This is equal to t to the power 7. From here, we just get the portions that have t again. This is t, 12 minus r, is equal to t to the power 7. Equate the powers. That's 12 minus r is equal to 7, meaning r is equal to 5. Meaning this is the 60th term, right? Add 1 to the r, right, to get the term. So this is the 60th term. That's what we want. And if it's a 60th term, we can actually get it. We put wherever there's r now, we can put our 6. So here we can put our 6. We can put our 6. Put your 6 there. To see if we can, to put our 5, the r is 5, right? The r that we bought is a 5. So this will be 5, this will be 5, and that's going to be 5. So this is going to be 12 choose 5. By the Daniel solving this, it's supposed to give you a 792. And this is supposed to be a 2t. This is a 7. Negative 1 over 2 to the power 5. So here this is supposed to be 792 with a negative there. Then it's supposed to be 2 to the power 7 and t to the power 7 and also 2 to the power 5. So this will go with that to give us 2 to the power 2. Then this will be 4. So this guy times 4. So the answer to this question is just negative 3168 t to the power 7. That's what we have there as our 60th term. Yeah, so hope this is okay. Then for question number 14, there's a separate video. It's titled Binomial Proof. You can see it on the channels. On the channel, it's just a 9 minutes video that just explains these two questions. So these were already done in a separate independent video. So this is already done. Then number 15, the condition for us using the factorials is that the n has to always be greater than or equal to the r, or rather we're just saying r has to be less than. For this to work, right, r has to either be less than or equal to n, not the other way around. So this is not possible. It's impossible for us to evaluate here because we are getting negative. You cannot have negative things, like let's say I have negative apples. No, you cannot have that. So we cannot choose 4 apples from negative apples. So both these two problems here, we'll say they are not feasible. So this is basically what we say, not possible. We cannot evaluate them. Yeah, that's what you have. So here we're saying the answer should be not possible. That's what we have for this. You cannot evaluate anything like this. Or even if I was to give you 100, choose 200. This is still impossible because you cannot choose 200 things from 100 things, right? Yeah, so this just checks the logical reasoning to what the principle states. So we are not able to evaluate this. That's your number 15. And your number number 16. So 16, they are saying expand the following in ascending powers of x as far as the terms in x to the power 3 and state the values for which the expansion is valid. So here I'm just going to show you, first of all, this is okay, this is perfect, it's already in a proper order, because the formula we need to use, this is still under binomial theorem, but when the power is either a fraction or a negative, and the first term has to be a 1. So this is the expression we're supposed to use. This is going to be the expansion that we'll be using all the time. This is a to the power that n minus 1, then n minus 2. This is 3 factorial. This is a power 3. Then the valid region. The valid region is simply modulus of whatsoever a is less than what? A 1. Whenever the first term is a 1, and whenever the power is either a negative or a fraction. This is a formula that we'll be using. And they'll always be telling you where to end, because this is always going to be a series. So like the first one, they want 1 plus x. So like question number 1, 1 plus x to the power negative 2. This is just going to be 1. So your a is x and your n is equal to negative 2. So just do the replacement. This will be negative 2 and x, then plus, this is negative 2 minus 1, 2 factorial, x, and this is going to be negative 2 minus 2, this is 3 factorial, this is x to the power 3, this is equal to 1 minus 2x minus 2 minus 3, there's a 2, negative 4, this is 6, x to the power 3, this is equal to 1 minus 2x plus 3, x squared, minus, this is 4x to the power 3, this is what we have, and the valid region here is just going to be modulus of x, because a is just x, then less than what? Less than 1. This is always going to be the expression that we use. It's modulus whatsoever is on the second term, provided the first term is 1, modulus, then less than 1. That's basically what you get. The same applies to this one here. We'll do the same. Here your a is x, then your n is just 1 over 3. We do the same expression. The modulus of x here is going to be the valid region, and then we expand this. Just being careful with the expression, because we're going to be dealing with a fraction now. Yeah, so this is going to be part 2. This is 1 plus x to the power 1 over 3. So we're going to have 1 over 3 times x, then plus 1 over 3 minus 1 over 2 factorial. This is x squared, 1 over 3 minus 1, 1 over 3 minus 2, 3 factorial, then x to the power 3, 1 over 3x, then this is equal to 1 over 3, this is negative 2 over 3, there's a 2 down, x squared, then plus 1 over 3, negative 2 over 3, then this is going to give us, when we find the difference here, that's going to give us negative, this is going to be negative 5 over 3, there's a 6 down, then this will just be 1 plus 1 over 3x. Here we can cancel this 2 and this 2 there on top, so we'll just get a negative 1 over 9 x squared. Here we can just get the 2 there, that's going to give us a 3. We're having an 81. This is plus 5 over 81 x to the power 3. So this is what you'd get. Then the valid region the valid region will still be modulus of x then less than 1. This is basically what you get. For the first one, this guy here, for number 2. Then for the third one, your a is negative. So the valid region here will be modulus of negative 2x, then less than 1. They all qualify here because you are seeing that the first term is a 1, right? We are saying it's a 1 throughout. Yeah, so we'll do this guy again. This is 1 minus 2x to the power 1 over 2. This is 1 plus half negative 2x. 1 over 2, 1 over 2 minus 1, then 2 factorial, then negative 2x to the power 2. Then we're having 1 over 2, this 1 over 2 minus 2, 3 factorial, then you have negative 2x to the power 3. So this is going to give us 1 minus x. This will be 1 over 2, negative 1 over 2. There's a 2 down. This is a 4x squared. This is plus 1 over 2, negative that. So negative 3 over 2. And this is going to be negative 8x to the power 3 over 6 down. Yeah, so you have to be careful with the fractions, but with time you get to be good. So this is going to give us a negative 1 over 2x squared. Here we can just say that the 3 there is 1, 3 there is 2, 2 there, 2 there is 4. So this guy is and this cancels. We'll just have a 2. This is going to be negative, negative, negative. That will be negative 1 over 2x cubed. Yeah, so this is what you get. The valid region, like we showed, is just going to be this. We can factorize the negative 2 outside. So this is the same as negative 2 and x like this. So this is the same as a 2. You can divide with a 2, divide with a 2, meaning modulus of x is less than half. This is like the domain or the valid region where x is going to be found for this whole expansion that we've done. Yeah, so however you do it, please make sure that you're careful with the fractions, and the answer here should have given you like this. So that's what you do for this question here. The same applies for number 4 and number 5. The difference is that these are put in a way that you have to rewrite them first. So like this guy here, 1 over the square root of 1 plus 2x. It's the same as 1 over 1 plus 2x with half there, because that's what the square root represents. Then this is the same as 1 plus 2x to the power negative half. So you are simply working out this. So where you have this here is the same as you're expanding 1 plus 2x to the power negative half. Same applies here. This you're expanding 1 plus x over 2 to the power negative 2. So just put it in this form before you start expanding. Then everything will be okay. Yeah, so you can attempt these last 2 questions. Then share with me what you're going to get. And I'll guide you on WhatsApp, just to see if you really understand the concept. So that's what you do for any question on number 16. So like here, the valid region will just be modulus of 2x less than 1. Here it will be modulus of x over 2, then less than 1. The expansion continues. Your a is this. Your n is going to be negative 2. So that's basically what you're going to do. Now question number 17. 17 is an application, and they specifically want us to use the binomial theorem to find the values for the following correct expression, correct to 6 decimal places. So we're going to start with the first one. How we'll do the first one is how you do any of these. Yeah, so I'll do the first one, then you should be able to attempt these other 2. Yeah, so the first one is just going to be, so this is number 17. Yeah, so 17a. There's a 1 plus 0, 0, 1. So hope you're okay with us writing it like this. This is the same as that. Then we're going to change this because there's a 1 here. We can just write 1 plus 0.001, we just need to have a 1 in front. Why am I insisting on us having a 1? Because we are seeing that the power that we are having is a fraction, and we can only expand if we have a 1 in front using the previous formula that we are looking at. Only the difference here is that where there is a here, you're going to put 0.0, say 0.1. So now we're just saying what we are worried about is 1 plus a to the power half. We expand it, this gives us 1 plus half a plus, this is going to be half minus 1, then you're having 2 factorial, then you're having a squared. So this is just where I'm going to end from. So this is going to be the same as 1 plus 0.001. Where there is a, we can now put back this, because we know to say a is 0.001, right? That's what we can do. So we can put back this expression. So this is 1 plus half 0.001 plus, this is going to be half negative half, then over 2, and this is 0.001 to the power 2. So this will just give us 1 plus, this is the same as 0.5 by the way. So if you don't have a calculator, you have to learn to do this first without 1. So this is going to be something like a 0.5 times a negative 0.5. Then there's a 2 down, this is 0.001. So how can you work out this without a calculator? We're just saying this is going to be 1 plus, multiply 5 by 1. 5 by 1 is 5, right? Then the decimal places here, here there's 1, here there are 3. So we're going to move back 4 times. 1, 2, 3, 4, 5. 4, right? 1, 2, 3, 4. So right here. Yes, so this. So 5, 1, 2, 3, and 5. Then here we get a negative. That's 0.5 times 0.5. That gives us 0.25. So this is 0.25 divided by 2. This other guy, 0.001 squared, is simply going to be the same as 10 to the power negative 6. Minus 0.25 divided by a 2. So we know to say 25, when you divide 25 by 2, what you get is just 12.5, right? Now I just say we move the point this side, so this is going to give us 0.125, because this is supposed to be 12.5, right? 25 divided by 2, but then you have to move the point 2 steps, so this is what we're getting. Then we're supposed to multiply it by this guy here. So this is 1.0005 minus, this is going to be 1.25 times 10 to the power negative 7. And if we find the difference there, so this is going to be so this is giving us 1.000499875. They want it to 6 decimal places, so this is going to be 1.123456. So it will be so this is what we get, because you cannot just throw away the 8. The 8 is going to give a 1 to a 9, 9 gives 1 to another 9, 9 gives 1 to the 4. This is what you're basically going to get. And you will notice that when you punch on the calculator, you actually get this answer. The square root, if you punch the square root of 1.001, you get this. So this is basically the method that we're using here to find the approximate values using the Pascal's, I mean the binomial expansion. So it's the same thing that you do even here. This is just going to be 1.02 to the power negative 2. You split it, 1 plus 0.02. This, change this to x, then expand. The same applies with this. This is the same as 1.03 to the power 1 over 3. Then I change this. So this is basically what you're supposed to do for question number 17. It will be confusing at first and also take much of your time because you have to work out all those two small numbers without a calculator, but you get familiar with them with time. Yeah, so you can try this. This is your task, this two. Yeah, so that marks the end of 17. We go to number 18. So number 18. So in question number 18, whenever they give you something like this, they're simply asking us to expand and give them the first 4 terms of the expansion given in this type of representation. So we're simply going to start by breaking it down. You let the numerator just come by the side so that you change the part which is the denominator. It looks like this. This is what you're having. We can change this and it becomes something that looks like this, having a negative power which can now be expanded using the previous formula we're from looking at when the power is negative. Now they specifically told us to only write for them the first 4 terms. So this is the main reason why I'm ending up to the 4th term as well here. So you do the usual expansion. This is what we did. Then from here, once you're done with the expansion of the right hand side, you now multiply every term by what is on the right. So 1 multiplies everything and x multiplies everything. This is what you're going to get. So we are only interested in adding the like terms. So this is how we ended up getting this part that we are having here. So this is how we do every other question on number 18. The same applies even to the next one. So the next one as well, here we'll do the same thing. We'll just write it as x plus 2. Then we'll have 1 over 1 plus x to the power 2. This is going to be x plus 2. Then this can be written as 1 plus x to the power negative 2. Then we expand this until the 4th term. Then we multiply every term by this. That's what we do there. The same applies here. 1 minus x. The guide down can be changed. This is just going to be 1 minus x and 1 over 1 plus x to the power half. Then you change it now. You're going to write it as 1 plus x to the power negative half. That's basically what you get. So this is how you deal with question number 18. Then now the part where we need to get the term independent of x is just the same thing like number 13. Whenever they say the term independent of x, they mean the term that has no x, meaning the term that has x to the power 0, right? That's what they mean. Yeah, so what term has x to the power 0 in the expansion of this? That's simply what they're asking for. So now we're going to have the following. So again, you can try B and C or number 18, and just for confirmation, you can just send your working, your rough work, so that I just respond to your rough work to see whether I've done the right thing or not. Yeah, so that's what you do. The number 19, we want to get the term independent of x. How we'll do 19, 20, 21, it's the same thing over and over again, just that the questions are different. So like number 19, let me just show it to you here. They want the term independent of x, meaning the term that doesn't have x. We'll say 6, choose r. We don't know what the r is. We know a is this guy. A is x squared. This is 6 minus r. We know the b is this to the power r. We equate this to x to the power 0. That's what you do. Then from the left hand side, we're going to get only the things that have x. So here the only thing that has x is x squared and 6 minus 2. Then here you're seeing there is a 1 over x to the power r. This is equal to x to the power 0. This here is the same as x to the power 12 minus this is minus r, by the way. So 2 times r, that's 2r. Then down you have x to the power r is equal to x to the power that. The bases are the same, so meaning we subtract the powers, we're simply going to get 12 minus 2r minus r is equal to, I'm just equating so this minus that is equal to that. So here you solve this. This is negative 3r is equal to negative 12, so r is just equal to a 4. So meaning, you know the nth term, right? Nth term says what? It's r plus 1. So this is just 4 plus 1. So it is the 5th term which is simply independent of x for number 19. That's what they want. It's the 5th term. You just end there. You can actually get it by replacing r here, right? You can get it. You see that by the time you're done, the term won't have x. The expression won't have x. So here it's the 5th term. That's the one that is independent of x. So it's the same thing that we also do on number 20 and 21. So I'm going to do number 21 and leave 20 for you because number 21 is a bit more complex. So that's the one I'm going to do. So let me just do it on a separate. So this is 2x This question 21 minus 3. This is x to the power 3. There's an 8 there. Yeah, that's what you have. So the one-third term that's independent of x, we said you first of all write the n, then put an r here, then write 2x, then you have 8 minus r, then you have negative 3, x to the power 3, then raised to the power r, this is equal to x to the power 0. Get the portions that have x alone, so I'll get x to the power 8 minus r. I also get this to the power r, that's going to be x3r is equal to x to the power 0. This will be x8 minus r minus 3r is equal to x to the power 0. Then this will just be 8 minus 4r is equal to 0. Negative 4r is equal to negative 8. Divide by this, divide by that. So r is equal to 2, meaning this is equal to 2 plus 1, which is just the third term. So it is the third term which is independent of x for number 21. So you can actually get it, and it's better that you actually proceed to get it by replacing wherever there was r, put back your 2, show us that the term won't actually have x. That's the better way to do it. So that's your number 21. So like I said, I'm leaving 20 for you. So this is your task to just see if you understand what we're doing. Then number 22. 22, they are saying, show that this is always going to be that, and also want to show that this is always going to be 0. So whenever they say show, it's up to you to choose any letter that you want, any number that you want, provided that number is satisfying the expression, and the choice of n has to be positive. That's the only condition. So for number 22i, I'll just use anything. So this is 22, I'll let you write let n to be equal to 3. Because we don't have a calculator, we have to give ourselves small numbers, right? So this is what they are saying, until we have n, choose n. This should give us the same as 2 to the power n. So I'll start with the left hand side and replace wherever there's n, I put a 3. That's 3, choose 0. This is 3, choose 1. This is 3, choose 2. Then this is going to be 3, choose 3. This is just going to give you, this is a 1, this is a 3, this is a 3, this is a 1. Total here gives you 8. Then the right hand side is just 2 to the power n. This is just 2 to the power 3. This is just going to be 8 as well. So that's the first case. That's part A, part 1. Then the second part is this part here, which is just going to be, if you put, I'll use 3 again. If I use 3 here, that's 3, choose 0, right? Then minus 3, choose 1. Then this is plus 3, choose 2. Then this is minus. This is minus 3, choose 3. This should give us a 0. This will be 1 minus 3 plus a 3 minus a 3. Or a 1, I mean. This is supposed to be a 1. You'll see that this actually ends up giving us a 0, hence shown. So this is basically what we have. Yeah, so this explains number 22. You have to decide or choose any number that you want, provided it's positive and it's small, because remember, you are not using a calculator, so it would be wise to give yourself a smaller number. Yeah, then to show that the left is always equal to the right. Then look at number 23. 23, they're simply saying 1 minus 2xp is expanded. The coefficient of x squared is 40, so we don't know what p is. All we know is that p, choose r. The first term is 1. This is p minus r. Here we're having negative 2x to the power r. They're saying 40x squared. This is what they mean. The coefficient of x squared is 40. This is what we have. So first and foremost, you know to say, according to this, r has to be x to the power r is equal to x to the power this, meaning r is equal to 2. So they're saying if I put p, choose 2, and this is 1, this is p minus 2, this is negative 2, x to the power, this is a 2, this should give us 40x squared. That's what they mean. So meaning, I'm just going to say my p2, this is just the same as negative 2x, I mean, the power 2 should be 40x that. So p factorial and then p minus 2 factorial and 2 factorial. This is just the same as 4x squared. This is 40x squared. This can cancel. This guy on top is the same as p minus 1. Then you have p minus 2 factorial. We have p minus 2 factorial and 2 factorial. This cancels. Then the 2 into the 4, that's going to give us a 2. Then we're just saying p and p minus 1 should give us what? There's a 2 there. This is a 2. Should give us a 40. Meaning, I can cancel, do this. This is p minus 1 is equal to a 20. This is going to be p squared minus p minus 20 is equal to 0. This here is the same as p squared minus 5p plus 4p minus 20 is equal to that. This is p minus 5 plus 4, p minus 5 is equal to 0. This is p plus 4. Then this is p minus 5 is equal to 0. So we just solving the quadratic. We know p can never be negative, so we go with this one. We discard this guy here. Yeah, we discard -4, so meaning p is actually equal to this. So according to the question, we're just using the binomial theorem of the nth term. We already found that p is equal to 5. They're saying the coefficient of x, meaning what's in front when we're only having x, what's the coefficient of x? So we're just going to go with the 5, choose r, then we have 1, 5 minus r, then we have -2x r. This is, there's an x there, meaning r has to be 1, so 5 choose 1. Because x to the power r is equal to x, there's a 1 there, so r is equal to 1. So now here we're just going to get, this is the same as just -2x, then there's a 1 there. This will just be a 5, then -2x, this is -10x. So the coefficient here is actually -10. Yeah, then the coefficient of this, they already gave us is what? They say the coefficient of this is what? 40. Yeah, so here, I think they did make a mistake. This was supposed to be something like x to the power 3, but then they made a mistake because they cannot ask something that is already given. Yeah, so this is what was supposed to be done. So this gives you a rough idea about everything you need to know under binomial expansion. There is a separate video that explains everything that you need to know and the details of what we are using to solve this question, just in case you need the background. Thank you so much for watching.